Okay, we're ready to start coding. So I'm going to open up PuTTY. I'm going to go to the IP address of my Raspberry Pi. I just use my default username, Pi, and password is Raspberry. Okay, and then I'm going to go to my desktop folder. And I'm going to create a new file called switch. So I use sudo, which allows me to do administrative functions, nano, which is the name of the application, the text editor, and then the name of the file that I want to create, switch.py, and then it should bring up a blank text editor. To make things easy, I'm just going to go copy and paste it from the web page. Let's see. So I go here, Underground Engineering Club, and then I'm going to grab the code. I'm going to copy it, Control C, and then in here in the PuTTY, I'm going to right click and that will paste everything. Okay, I click on Control X to save. It says save modify buffer, yes. Do I want to name it switch.py? I do. I just click on enter and it's all saved. But before I run it, let's go take a look at the code and just talk a little bit about what it does. So I'm just going to click the up arrow here. I'm going to reopen that file. Okay, so the first two lines here, I'm just importing in libraries, Raspberry Pi GPIO, and then the time library. And before I go into the blink, let's look at the main program. The main program, okay, set mode GPIO board, if you remember from previous lessons, that allows me to address the GPIO pins using the number of the pin, like 1, 3, 5, 7, rather than the GPIO 3, 4, etc. So that's what that does. The LED is coming out of, we're controlling it through pin number 37 down here, right here. This is the wire going into the LED, 37. And so I'm setting that pin, number 37, as a out, general purpose input output. And I want to set it to out. Okay. So let's see, on the switch, I want to sense if the switch is being clicked or not by looking at pin number 33 right here, fourth from the bottom. That's this orange line here, and you see that it's right here on the other side of the switch. So that's what I'm doing on this line. And then I create a variable called go, and I set it to false. And then I create a loop, a while loop. And when I say while true, and then do a loop, that means basically do this forever. And your Sumobot, when you program your Sumobot, you're going to want a while loop like this also. So whenever your Raspberry Pi boots up, it's going to go kind of into this infinite loop, and it's going to be at first in a standby mode, and then when you click your switch button, then it's going to go into your active mode where it starts to actually try and find something and push it out of the ring. So let's see. What I do on this first line within the loop is I just want to print what the state of go is. And so initially it should print false. And now it's detecting if the switch equals 1. That means did I click the switch? If I did, if go used to be false, turn it to true. Otherwise, if go used to be true, then turn it to false. So I'm just changing the state of the variable go. So if it used to be false, then turn it to true. If it used to be true, then turn it to false. That's what happens when I click on the switch. Okay, and what's going to happen is when go equals false, then it's in standby mode. And I'm just going to make the LED just blink, letting you know it's in standby mode. But if we click the switch button and we switch the state of go from false to true, then it's going to go and do this other thing. For now, all we're doing is we're just setting the LED onto always on mode. See, so GPIO output, the LED number, which is I believe 33, is going to go to high, and the LED is going to be always on. Okay, so just to explain one more time, if go equals false, then it's going to be blinking. Otherwise, it's going to be always on. And when you click the switch, it's going to change the state of go from false to true, and from true to false. So if I push it once, it's going to start blinking. If I push it again, it's going to be always on. And now I'm just going to review up here what the blink function does. Basically, up here, I set the LED output to high, wait 0.2 seconds, and then I set it to low, turn it off, wait 0.2 seconds. So it's just going to blink, 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 blink. Okay. So I'm going to save this, Control X. And then I'm going to run this by typing sudo python and the name of the file, switch.py. Oh, okay. And then you see down here, the LED is blinking. And you can see on the screen that the state of go right now is false. When I click the button, oh, now we just changed the state of go to true, and if you look down here, the LED is always on. Click it again, false and blinking. Click it again, true and always on. Okay, so it looks like a small thing right now, but when you have your Sumobot, I'm going to do Control C to stop that and go back into the application. So I'm going to go back to Nano, look at the file here. And so when you're making your Sumobot, you want to come down here, and when go equals false, you're probably just going to keep this the way it is. Your LED is going to blink, your Sumobot's going to do nothing. But when you're in go mode, your active mode, you're still probably going to keep this, make your LED always on. And then below that, you're probably going to call some function and start making it do stuff like turn around and look for your opponent. And then within that loop, then if you see your opponent, then you'll want to make the Sumobot go forward, etc. So you want to save this little space right here for what your Sumobot is now actually going to do. Okay, that's it for the switch.